All right, let's look at the practice exam 3, problem number 4. All right, so we have a solid inside the sphere. So this is a unit sphere since the radius is 1. And above the xy plane and below the cone, z equals square root of x squared plus y squared. All right, so I already drew the picture here. So you have this solid here. All right, then we want to set up a triple integral in spherical coordinates for the volume of this solid. All right, so let's do that. All right, so first, let's see, we have the, part of it is already, filled in. So rho squared sine theta, sine phi, d rho, d theta, d phi. Right, this is just the volume element, right? So this is just the volume element for spherical coordinates. All right, so all we have to do is come up with the lower limit and upper limits. All right, so let's do that. All right, so first one is, let's see, with respect to rho. All right, so we have to see how the rho starts from 0. Right, so we're going to fix theta and the phi. Right, so we basically fix the angle. So angle, let's see, theta is an angle from here, so I'm going to have, let's see, right, so this is the angle theta, fix it, and then phi is the angle from the positive z-axis, so this is going to be phi there, right, so we're talking about here, right, then you see that it's start from the origin, so phi is equal, rho is going to be 0, so that's understandable, that's right there, rho equals 0. Then you can see that for fixed theta and phi, rho extends all the way up to wherever it hits the sphere, and whose radius is 1. So we know that it's going to go from 0 to 1. Right, so that's the range of rho. All right, theta is pretty easy. Theta, since you have to go all the way around to cover that, so it's going to go from 0 to 2 pi. All right, and the phi is the little tricky one. So it might be a little bit hard to look at the three-dimensional picture. So why don't we look at the cross-section by the YZ plane. So I drew a picture here. All right, so this is a cross section of the solid. All right, so this is determined by the cone here. And since we're looking at the YZ plane, so x is going to be 0. So this equation in here, so you have, let's see, z is equal to square root of x squared plus y squared. All right, since here x equals 0, so we have a z is equal to square root of y squared, which is the absolute value of y, or I'm just going to say y. All right, since we're only looking at the positive one here. All right, so we're looking at the equation here. So actually, maybe I should have done this is going to be actually a absolute value of y. So, but this one has an equation. This is a z is equal to y, and the other one is z equals negative y, right? But I'm going to look at that z equals y, right? So z equals y, slope is 1, so it means that this is going to be 45 degrees. So we know that the phi, this angle right here is 45 degrees. So phi here is pi over 4, right? And then if you go all the way to the y-axis, that would be phi is equal to pi over 2, because that's 90 degrees, right? So you can see that the angle phi is going to start at pi over 4 all the way up to pi over 2. So that's why you're going to have pi over 4 to pi over 2. Right? So that's how we set up the triple integral. Right? So let's separate them. Right? So the first one with the row goes from 0 to 1, so it goes here. Theta goes from 0 to 2 pi, right? And phi goes from pi over 4 to pi over 2, right? So let's evaluate this, right? Antiderivative rho squared would be rho cubed over 3, and then you're going from 0 to 1, right? And the antiderivative of 1 would be theta, and it's going to go from 0 to 2 pi. Antiderivative sine of phi is going to be negative cosine of phi, and it's going from pi over 4 to pi over 2, right? So this is going to give us 1/3 minus 0, so it's 1/3. And here this is 2 pi minus 0, so it's going to give us 2 pi. Then if you plug in pi over 2, cosine of pi over 2 would be 0. Minus, there's a negative sign, so it's going to be plus. Right, cosine of pi over 4 would be 1 over square root of 2. Right, so this is going to be, 2 pi divided by square root of 2 would be square root of 2 pi. There's a 3 on the bottom. Right, so this is the volume of the solid given here. All right, that's it. I hope that this was clear.